For our next lesson here, we're going to be looking at parallel lines and triangles. And we're going to begin this with the parallel postulate, which simply states, with any line and a point not on that line, there exists exactly one parallel line. So what this means is that if I have line AB, and out here I have point P, that I can only draw one line through P that would be parallel to AB. Again, this makes sense, and it is a postulate, not a theorem, so it is one of those basic concepts that we're going to build off of. And as we use this, we're going to be able to apply this idea and others to triangles so that we can create information about the triangles. And with this, we're going to begin looking at, which is theorem 11. Theorem 311, which is the triangle angle sum theorem. Now this theorem states the sum of the angles of any interior, the sum of the interior angles of any triangle is always 180 degrees. And the way we're going to build this is by using the parallel postulate. So if I have a line here, and I drop a couple of points on it, again, I'm going to call them A and B. Then I have a point out here. I'm going to call it C. I'm going to draw a line through C and label it as being parallel to line AB. So now I'm going to create a triangle here by extending a few rays. I'll have ray AC and ray BC, creating triangle ABC here in the middle. Now, using some of our angles and congruencies that we know, we're going to start establishing some characteristics of this triangle. For instance, angle A here is an alternate interior angle to this one. And then angle B is alternate interior to this one. And we know up here along the line, parallel line that was created through C that a straight angle is 180 degrees, which means that this overall angle up here is 180, and the three pieces that make up the angles of the triangle would also be 180 degrees. So we're able to piece it together through justification like this, and we'll have more opportunities to do more formal proofs at a later time. But with this angle sum theorem that we get for our triangles, we're able to find missing parts of triangles through it. Given this triangle ABC, and setting a line segment, BD, we're able to start labeling and working with different parts of the triangle. In triangle ABD that was formed, we have two angles, 59 and 43 degrees, and then angle X being our unknown. So now we'll be able to use arithmetic to go through and calculate the value of X, because we know by the triangle angle sum theorem that 59 degrees plus 43 degrees plus X has to equal 180. Combining like terms, we have 102 plus X equals 180. Subtracting the 102 from each side of our equation by the subtraction property of equality gives us X equaling 78 degrees. Well, now we know that X and Y form a linear pair, so X plus Y has to equal 180. 78 plus Y is 180. Subtracting our 78 from each side, we come out with Y being 102 degrees. Then we can go through and find Z based on, I neglected to mention that this angle here was 49 degrees. So using the triangle sum theorem in any direction, we can say that 49 plus angle y plus angle z has to equal 180. Well, 49 plus 102 plus z is 180. Forgot to put my z in there. 49 and 102 is 151 degrees. So plus z is 180. Subtracting the 151 gives us z equaling 29 degrees. Sorry, I forgot to label that 49 to begin with. But we can begin looking at different characteristics and finding missing angles with only a couple given. But also in here we have one other theorem that comes into effect, and that's theorem 312, and it has to do with angle y. Let's look at theorem 312 more formally on its own. Theorem 312 is the triangle external angle theorem, and it simply states the measure of each exterior angle of a triangle equals the measure of its two remote interior angles. And what this means for us is that we have interior angles located inside of the triangle and exterior angles which are formed when one part of the triangle is extended out. Remote angles are those that are distant from. So for here, remote angles are here and here. Now using our triangle angle sums, we can conclude, if we were to label this as being x, that 37 plus 70, that should be 70, plus x has to equal 180. So we have 107 plus x equals 180. Subtracting the 107, we're told that x is 73 degrees. So I'm going to replace this x with 73 degrees. Now if we were to call this exterior angle z, we know that angle x and angle z form a linear pair, so that means that 73 degrees plus z is equal to 180. Now subtracting the 73 from each side gives us z equals 107 degrees. And you'll recall that the sum of the interior angles that we knew was also 107 degrees. So on an informal basis, this exterior angle here is equal to the sum of the two remote angles. And we'll be able to use this moving forward as we go through different parts of geometry, and will be very helpful when we're trying to prove congruence and similarity in upcoming units. So make sure you have these concepts and ideas down and are ready to use them as we move forward.